Welcome. In this video I'm going to show you how you can obtain the effect size measure Fey using Python and my stikpetP library. I'm currently using Python version 3.8, but this should also work in later versions. This is an effect size measure that could be used after a goodness of fit test. It actually takes the chi-square test statistic and divides it over the maximum possible chi-square statistic and then takes a square root out of that. This video I will be mostly showing how you can obtain the measure, not so much if you should. There are alternatives. I haven't found any rules of thumb for this one, but you can actually convert it to Cohen's W. And for that one there are some rules of thumb, or if you want to use those. To show you how this can be obtained, I'll need some example data, so I'll load in pandas, and then I can use their readCSV function to load in the general social survey data from 2012 that I adjusted for some example purposes. I actually don't need all of its data, I just need one nominal field, so I'm going to be using the marital status as my nominal field, as you can see here, and that was called mar1. To give you a quick impression, the value counts of those, so for example 79 people indicated that they were separated. Now my library is not available directly via pip install, but you really need to specify the entire link as shown here. And once you've installed it once, you can import it just as any other library. The function will actually need a chi-square value, the minimum expected count, and the sample size. But if you run, for example, a Pearson goodness of fit test using the stikpetP library, then you actually have all those results already in the test results. The chi-square statistic is there, the minimum expected count is there, and the sample size is there as well. Once you have those three values, you can use the esv function. It requires those three as input, and if we put that in, then we actually get ourselves the result. So in this case, Fey was 40%. We could convert this to a Cohen W. You can use esconvert for that. So my Fey value from Fey to Cohen W, and that also requires the minimum expected count as a proportion, so divided by n. So Cohen's W would have been 0.80, and then I can use th, thumb rules Cohen W, to interpret that, which would classify it as large. Alright, and that was about it. I hope this video was helpful, and thank you for watching.